Okay, so for this current talk, let me introduce Dave Klein. Dave's a software developer. He's an author, a trainer, a mentor, an explorer. Been finding ways to solve problems with software for 25 years and having a great time doing it. Dave has spoken at and organized tech conferences and user groups. So I'd like you to give a big welcome to Dave, and off you go, Dave.
All right. Thank you, Jay. I'm thrilled to almost be here. I wish we could have been there in person in beautiful central Pennsylvania, maybe next year. But welcome to this talk. The talk is Apache Kafka, not your father's message queue. Now, I don't know how many people are familiar with that phrase. It's from an old car commercial years ago. But I love that the concept behind it. There are technologies that come along that we have an impression of, and often that impression is not quite accurate, and that's the case here. Before I started working with Kafka, well, let me back up a little bit. Brief introduction of myself. As Dave said, my name is Dave Klein. I've been a developer actually so almost 30 years, 28 years. I've been doing in software development in various roles. And I've always loved technology, loved learning new things. And I've also always loved the community around technologies. Years ago, I was involved in another really, at the time, vibrant community with the Groovy and Grails community, which I really enjoyed. And 10 years ago or so, wrote a book on Grails, and that was a great experience. And after that, it kind of started fading away. That community kind of died out, and I've missed that. And I hadn't really seen it again until I got hooked up with the Apache Kafka community. And it's very similar in a lot of ways as far as just the welcoming attitude, the desire to learn and explore, and just the excitement of what's on the horizon. So before I started working with Apache Kafka, though, I had heard of it, and I lumped it in with other messaging services, right? ActiveMQ, RabbitMQ, those kinds of things. And I didn't really know much about what it was until I started using it on a recent job that I got. And as I learned more about it, I started realizing that it was so much more than that. And that gave me the idea for this talk. It's just a way to introduce Kafka to those who may not be familiar with it and may have heard of it, like I said, just as a messaging service. So let's see if I can move my slides around. Nope. All right. So there's another old phrase. One of these things is not like the other. I don't know if any of you are familiar with that from Sesame Street. But just a pattern building kind of exercise that Sesame Street used to do, and it shows different objects, and you have to figure out which ones were different. And so these are logos from various messaging services that people might have lumped in together. And in fact, they often are still lumped together. Some software frameworks that provide interfaces to messaging services where you can plug in your various technology into their interfaces. And Kafka is just one of the many that they can plug into their messaging interfaces. And you can use it that way, and it will somewhat work, but you're just missing out on a lot of the power of Kafka. In fact, in general, I don't really like those kinds of tools that try to give you the least common denominator over several different technologies. Each different technology has its own strengths, and I think you take advantage of those strengths and you work with them directly. But that's a side story, maybe another talk down the road. But like I said, Kafka is not just a messaging service. In fact, it's not a messaging service at all. Kafka was invented at LinkedIn, and the team that invented it, created it, they did it because they were trying various messaging services and messaging software to meet their needs, and it wasn't working. So they created Kafka, which filled the gap that they had, and it just took off from there. Became very popular and widely used in LinkedIn, and then it was contributed to the Apache Foundation, and just kept on growing from there. I think at the end I got a slide showing on the Apache website that shows the adoption rates, or the current adoption of Kafka, and it's pretty impressive. It's just taking off, and it's a very powerful technology, but it's not a messaging service. So what is it? PubSub? Yes, kind of. Structurally, it is a publish and subscribe framework, and many companies use it for that use case, and it works really well. But that's selling it short. I mean, there's so much more that you can do with it than just publishing and subscribing. You can be sending messages and receiving them. I mean, but you can do a lot more with it than just that. And a lot of it comes down to the way that you view it and the architecture. So I think that the real strength of Apache Kafka comes when you adopt it as the heart of an event streaming platform. And you can use the various components in the Kafka ecosystem to build out some really impressive applications and enterprise-wide architectures. This is a simple diagram with some of these, and we'll talk more about these ideas a little bit later on. But first, I wanted to focus in on the concept of an event, because that really is a key to taking advantage of Kafka, is to recognize the power of the concept of an event. Now, event contains notification and state. So a notification tells you something happened, and then the state gives you information about what happened. Now, every event that comes through Kafka will also have a timestamp, so you'll know when things happened as well. But these two concepts here, notification and state, combining those, you can just do so much. The simple examples I have here, right? So an event might be something that happened that requires some further action, like an order is placed. And so another service will pick up that event and look at the information about the order and do something with it. Other events might just be historical, like system logs, or some things might be, have multiple purposes, like the temperature reading, right? One application might pick up the current temperature reading and just display it on the sign like you see out in front of banks. Another service might pick up the temperature reading and use it to decide whether to adjust the thermostat or the heater, right? Turn it on or off. Those are silly examples, kind of, but the idea is that one event could have multiple uses. And if you think about it too, an event can be used to carry a command. So it might be like the order placed. You look at that as a command, as something to do now. But even a command or a request is an event. And so when some other system or individual makes a request, that's an event. And by modeling that as an event and thinking in that paradigm, it really just opens up a lot of doors. So, and like I said, pretty much all data that we have in our applications, enterprise-wide, it all originated as an event. A database you can look at as a static view of the events that have happened, but it's kind of like a dead end view, right? It's just all you have is the current state. You don't know what led to that. The events and the history of those events tells you how you got to where you are. And so by having having those events in an event stream, you just have so much more options. You can replay events if you make a change to application. There's just a lot of things you can do with it. So it's just, like I said, the terminology matters, I think. And so you'll often hear, and I'll probably even use this terms of record or message in speaking about Kafka. And those are valid terms for how you work with Kafka. But I think keeping in mind that concept of an event is really important. It's a logical construct. It's not necessarily a physical thing, but it's a very powerful tool. And it helps us to get the most out of Kafka, I think. So another thing is how Kafka stores these events and receives and stores them. And that's another really very simple, deceptively simple concept. It's just a log, right? At the heart of Kafka is a log. It's a append-only immutable log of events. Now I'm showing here is a single log, but in Kafka you'll call this log a topic. Most topics in Kafka will have multiple logs, though, called partitions. And that's just for scale and for increased throughput. You have multiple partitions, but they all each partition is an append-only immutable log. So once something goes onto the log, you can't change it, and you can't insert you can't insert something in between two different events that are in the log. They always go on in order, and they always stay in that order. The position that an event lands is called its offset, and that stays there permanently. Now, speaking of permanently, a Kafka topic can hold events permanently if you choose. Obviously, space becomes a concern. Recently, tier storage is added in some flavors of Kafka. I'm not sure if it's reached to the open source part yet. I think it's on its way, though. But with that, you can more affordably keep data in Kafka topics forever, with older data being moved off to an object store like S3 or something like that, and the more active data being on your SSDs and ready to go. But you still work with it all the same way. It doesn't change from the user perspective, other than obviously latency as you start trying to read the older messages that are stored off in different storage. But the time that an event stays in a Kafka topic is up to you. You can configure it at the topic level. You can set a time, like in hours or days or weeks or years, or you can set a size limit. So you want this topic to grow over a certain number of megabytes or gigabytes, whatever you choose. And then ones that pass the threshold will gradually be dropped off. But other than that, it's like I said, it's basically a permanent and mutable log of events. And this construct is like I said, very simple, but very powerful in that it allows you to work with that data in very predictable ways. So one application can read messages from the topic, and another application can come along and read those same messages, and they're getting the same messages in the same order. Same message, same events in the same order. So it's allows you to build some very, very powerful applications. So let's look a little bit more in depth at what the events are, how they're built. So in Kafka, the two main components of an event are a key and a value. There's also, like I mentioned, a timestamp, and there's also metadata that can be added. So there'll be things like I'm not sure exactly what things come in the metadata off the top of my head, but you can also add, I know you can add to the metadata. So metadata is like basically a hash map that you can add extra information to each event. But the main things in it are the key and the value. They can be anything. They're just on the topic. Once it's written, it's just bytes, right? Everything is just converted to bytes when it's on the written to the log. So, you can use any kind of value for both the key and the object. They can be complex values, objects, anything you want. But more often, you're going to see something like in this image up here now, where the key is a simple data type, a string, or maybe perhaps an integer, something just to use to keep track of what that value represents. And then the value is usually a more complex object, like a JSON object or Avro or protobuf. Those are the most common formats. But again, it can be anything you want as long as you can serialize and deserialize it. You can use any type of value. So in this example, I said the key is just a simple string. Now the key is actually optional. The value is the main thing in an event. It's the information about what happened, and the thing that happened can be determined based on the topic that's written to. Often topics are tied to the type of an event that's happening, or you could also use, like we have an example here, an event type, and that's just another architectural design. I work in some systems where you use one giant topic with a whole bunch of partitions, and all events land there. And an event type determines what type of an event, what to do with it. And then those are parceled out to different topics based on those event types. So again, there's different ways you can use this. But the key, although it's optional, it's very important because it provides the ordering. As I mentioned before, that the messages are written to a partition in order, and that order is always guaranteed and always is fixed. But if you have multiple partitions in a topic, then you don't have a guarantee of ordering if you don't have a key, because a key will make sure that each message or each event is written to the same topic. So just a quick little example of how that works. As events are landing in the topic, here's a topic of 3 partitions. So as events are landing here, they'll land in a topic based on the key, or land in a partition based on the key. So what happens in the default partitioner is that the key is a hash of the key is taken, and then that's modulo with the number of partitions. So 3 partitions in this case. So the result's going to be 0, 1, or 2, and that'll tell it which partition to write that event to. And then as they come in, each one is assigned to just the appropriate partition. And like you see, events with the same key will always be written to the same partition, and that will allow you to guarantee that ordering, so that all events with A1 are always going to be in that same partition in the order that they're written. So, and in this example, I have them nicely spread out across these, but it may not always be that way. It really just depends on how the hash algorithm works out. Now, you can have a situation if your keys are not very widely distributed, you might end up with a hot partition. So, for example, if you're using a customer ID, you could end up with a major customer could overload the partitions. So you might want to look at different strategies in that situation. If you've got a customer that represents 80% of your business, you might want to put them in their own topic even. But there's different ways you can handle that. You can also create a custom partitioner if you need to. If the default one isn't doing what you need, you can create your own algorithm for designing where to put things. And then also another thing you can do is, and we'll get this when we start talking about producers, which is up next here, you can send an event to a specific partition. So you can, if you wanted to have the code in your application to do the partition, you could do that as well. It's not very commonly done, but it can be done. So events are written to the topics with a producer. Now, a producer is part of the Apache Kafka client libraries. And the one I'm most familiar with, and probably the most common one, is the Java libraries, but there are libraries out there for most of the popular languages today. There's C#, Golang, Python, and several others that are widely supported and actively used. So you can use the producer or the client libraries to build your application. So the producer isn't an application on its own. It's a component that you add into your application. Speaking in terms of the Java one, which I'm most used to, you'll have classes that are there that you can use to produce events. So you have a producer class, you can instantiate it, you give it some configuration information. You need to give it one or more of the brokers that you're going to be working with. Speaking of which, I haven't mentioned brokers yet. So let's back up a bit and talk about the three major components in the end-to-end Kafka story. At its core are producer, broker, and consumer. So the broker you can kind of think of as where the topic is. The brokers manage the topics. That's about all they do really, is manage the topics and the partitions. So partitions are spread across. If you have multiple brokers in a cluster, the partitions for a given topic will be spread across those brokers. There's usually also replicas, which again are optional, but it's a good thing to do. So you have replicas of each of your partitions, and that gives you fault tolerance. So if a broker goes down, any partitions that were where the lead partition was on that broker, the responsibility will be handed off to a replica partition. It'll become the leader. So there's leader and follower replicas for each partition of a topic. And again, they're spread across multiple brokers. So this gives you the fault tolerance and as well as the scalability. So the broker handles the topics, the producer sends events to the topics, and then we'll get the consumer in a bit that reads them. But the producer and the consumer are part of the client library. So with the producer library, you can create an instance of the producer, then you can create an event using still the standard objects that are provided in the library. I think it's record is the most common class you use for that, a producer record, and then you can send it. Now, when you send it, that's where you can actually give it a partition if you want to. Normally you don't, and you let the partitioner decide where to put it. If you're not using a key, the partitioner by default will just use round robin, which gives you very good distribution. So if you're doing things like system logs or something like that, where you really don't need a key or have a key, you can just let the round robin default partitioner take care of that. So the producer writes the events one by one, and I lost my focus again. Sorry, excuse me. My slide deck isn't cooperating. Okay, so it writes them one by one in order as we talked about earlier, and that position that you see, the number below the slot, is the offset. Now the consumer comes along. The consumer is also part of the client library, and the consumer has a lot of smarts built into it. The producer does as well. I should back up again. Let me touch on some of those things. The producer, along with sending the data and telling it where to go, it also has the information for the partitioning. It also has the information for for compression. So if you're using compression, which is a good thing to do to increase your bandwidth or your throughput, so that's all handled by the producer. There was one other thing I was going to mention the producer does. Now I'm drawing a blank. The broker is basically dumb. All it does is manage its topics and make sure that they're balanced appropriately and that they're active. But the producer and the consumer are where most of the smarts are at. And again, those are in the client library, so you don't have to write all that yourself. You just use the objects that are provided for you. So the consumer then comes along and starts reading the events from the topics in order again. Now you can seek to a specific offset and start from there, but you always just read forward in order. Generally, you start either at the latest, or at the beginning, or the last consumed one, which we'll get to that in a minute. So the producer and consumer are completely decoupled. They don't know anything about each other. They can work at their own paces. The producer can just keep on producing. If the producer slows down and the consumer catches up, it'll just read until there's no more events there, and it'll just sit there waiting for the next ones to come along. And periodically, the consumer will record the most recent message or event that it processed. So it's committed offset. And the committed offset is really an important tool. It's used to make sure that you don't miss anything. So if a consumer goes offline, the producer will just continue producing and keeps on sending those events one after the other, as long as there's more stuff coming. And even though nothing's being consumed, it doesn't matter to the producer. It's not going to get backed up or jammed or anything like that. It'll just keep on doing its work. And when the consumer comes back online, it'll use that committed offset to see where it left off and just pick up from there and keep going forward. And there's metrics that you can get to see if there's a lag, if consumers are falling behind producers. Again, the producer won't care, but you might care. And so there are metrics that you can get that will tell you those kinds of things. So now, as I said, the producer and consumer are completely decoupled. They don't know anything about each other, but they do need to know about the events and how to read them, right? Because you have to be able to serialize and deserialize them. And so for that, a schema is extremely helpful. Again, not required. You could have that information just hard-coded in your applications, in your producer and consumer applications. And if it's a small project and you're the only developer on it, that might be sufficient. You know what you're putting in, you know what you're getting out. But if you're working with multiple teams and with multiple different topics with different types of events on them, a schema becomes very important. So the schema registry is another component. It's another application that you run, and it's not part of the Apache Kafka itself, but it's another source available free tool to use provided by Confluent. And it's very, very helpful and very valuable tool. So with that, a producer sends an event and passes the schema with it. And the first time it does that, the schema registry picks it up and stores it. After that, it'll just use the key that it gives it. It can be used by both the producer and the consumer to say, this is the schema of the event that I'm working with. When the consumer reads an event, it grabs the ID off of that, after the first few bytes of the event, and goes to the schema registry, gets the schema for it, and it can decode it from that. So, and the schema registry also enforces schema evolution, so you can tell it whether you want that to be full compatibility or backwards compatibility, forwards compatibility, different options like that you can set, and it'll keep track of those things for you and make sure that you're not breaking your users. Another part of the Kafka ecosystem is Kafka Connect, and this is one of my favorites because it allows you to bring Kafka into an environment without affecting existing applications, really. In this one, we're looking at a picture of a Kafka Connect source connector. Now, first of all, back up, Kafka Connect is basically just an abstraction over producers and consumers, right? So it knows how to read and write from Kafka. Then you add in a plugin called a connector, which knows how to work with the external system. So for a source connector, you'll add in a connector that knows how to read from a database or read from an application like Salesforce, or reads from text files, or reads from HTTP. So these different connectors are available, and there's, I think, almost 200 of them out there right now that you can use for all kinds of different purposes. They'll read that information from those external sources and send it to Kafka topics. So if you have an existing application, you can just hook up a connector to the database of that application, or to the application itself if there's a connector for it, something bigger like Salesforce, and you can start getting that data also into Kafka. It doesn't affect your current applications at all, but it makes the data available to other applications that you might want to add on. It just opens up a lot of opportunities. And then there's sync connectors as well for writing data back out to different external systems. So this is a way that you can have downstream applications can get the data in the source that they're expecting it for their own purposes, without interfering with the rest of what your applications are doing. So Kafka then becomes like this central data plane that you can just have all of your data flowing through there, and it can be pulled from different sources, sent to different sources. And along the way, you can do a lot of great things with it, building your own applications off the topics directly with using consumers and producers or some other tools we're about to talk about. So one of those other tools is Kafka Streams. This is part of the Apache Kafka project and or a sub-project from it. And it's a very powerful tool. It, again, builds off the consumers and producers. It consumes events from the topics, but then runs them through a stream with a whole bunch of different operations that you can use. Kafka Streams provides a DSL, which I'm showing some of the operations in the DSL on this slide here. And there's a lot more of them that you can use. And you can do quite a bit with just the DSL alone. If you need to go deeper, there's also a processor API that allows you to do even more and create your own operations. But each of these operations, or most of these operations, will return another, what they call K-stream object. And so you can chain these together to do all kinds of filtering, mapping, aggregations, branching. And then you have terminal operators like two. So when you're all done with your processing, you write your end results out to another topic or topics. So events can come in one topic, and they may have been a lot of other topics. I mentioned an application that I worked on before that had one giant topic with thousands of partitions. And it all events landed there, and then there were some rules that were in routing that was done and through a Kafka Streams application, and then it wrote those events back out to multiple different topics. So that's a relatively common use case, but there's just so much you can do with Kafka Streams, and as you build out your topologies, as they call it, they get pretty complex, but there are tools out there to help you visualize them, and it's a very powerful tool. It is Java only, so it's a Java library that you can include in your applications. I think there's somebody working on a C# equivalent, so there's no reason somebody couldn't write Kafka Streams type library or similar library in other languages. It just matter, people's time and someone getting it done. So like I said, there's one in the works for C#, but you can probably Google and find that. But it's a great library. If you use Java already, it's a great way to interact with the data in Kafka. So speaking of Kafka Streams, in Kafka Streams, there's, like I mentioned, the K-stream. There's also another construct called a K-table. Because if you think about it, oh, wow, is my stuff not showing up here? Oh, I've left my animations on. Sorry, I'm going to get this filled in real quick. So I just want to use this as a static picture. So you can look at events in a topic as a stream, which is a common way to work with them. And in Kafka Streams especially, that's what you normally will start with, as you'll load in read a stream of data from a topic. But the same data can also be represented as a table. So Kafka Streams has a K-table, which is just a snapshot of the current state of all of the keys in your stream. So here we have those A1, B1, C1, D1. So the stream shows what's happened with each of those keys all along the way. The table is just the current values. And so you might use a table for joining for more static data that doesn't change as often. And you can do joins in Kafka Streams with a table and a stream. So you can maybe have a user table that has your user information. And when some event comes through that user is doing something, you can join up that with the user ID and get the user information and write something to another topic that has the information about that user and what they just did. So the tables are very useful for that. They all come from topics. Now, one thing to mention here, since we're talking about this, is that a topic will normally have all of the events that's been written to it, like we talked about earlier, right? It's immutable, it's semi-permanent, as long as you want it to be. But you can configure a topic to be compacted. And a compacted topic goes well with a table. So if there's data in a topic that you are going to mainly just use in the form of a K-table in your Kafka Streams application, say, then you might want to configure that topic to be compacted. And what that will do then is it will tell Kafka just to clean up all the older keys, all the older events for that same key, so that all you're keeping is the most current event for a given key. So this might be something you would use for something like a lookup table. If you're using a small set of data that you use in your Streams applications, and you're going to keep looking up to get those values for it, then a compacted topic might be just what you need for that. it's an efficiency thing. You don't need to use that. You can have a table based on a very long topic that's got years old data if you want, but you'll only see in the table, you only see the most recent ones. So that's streams and tables. And so it's a neat idea how people talk about the stream table duality. They really are both just different views of the same information. Now, one thing to keep in mind with the table, though, is that it's lossy, right? Once you turn something into a table, you don't have the history of what led to that current state. So the stream has that and keeps that history. Okay. Another tool that's available, and so again, this is source available, provided by Confluent. You can use it freely. It's another application that you install, so you have a cluster of ksqlDB servers. ksqlDB is built on top of Kafka Streams, but it's great if you're not in a Java shop or you don't work with Java, don't want to learn Java. You can build a lot of the same types of stream applications that you could with Kafka Streams. You can build it with ksqlDB using a SQL dialect. And I have a really simple example here, but you can get pretty complex with these, and you can create streams based on topics. You can create tables based on streams. You can join streams and tables and come up with new results and new topics. So you can do quite a bit with this tool. And then with Kafka, with ksqlDB, you can do like your Kafka Streams applications where you just do all your processing and write the output to another, that topic from another application. But you also, with ksqlDB, there's a REST API, so you can interact with the data through REST. You can send queries to it with a REST to the REST API, but you also can read. You can read the current data, current state. So there's two types of queries in ksqlDB. The one I'm showing here, where it has the keyword emit changes on there, if you can see that on the slide in the center bar, that tells it as the data's coming into the topic, continue to process this query and give me the latest results. And so the results will keep scrolling up and you'll keep getting more of them. That's called a push query, and that's pushing the results back out to you constantly. A pull query gives you just the current state. So you can execute a pull query and get to the current state of a stream or table. And so you can make a pull query through the REST API from another application. And that gives an application that isn't a Java application a way to interact with the topics in a stream application built with ksqlDB. So it's another powerful tool. It is, like I said, it's another application you have to install and maintain and run in its own cluster. ksqlDB does include Kafka Connect as well, so you can install and configure connectors right through with SQL statements in ksqlDB, which is another handy feature of that. So you can build out a pretty complex system with ksqlDB. And now let's look at just bringing this all together. So you got your events being produced and consumed, produced to these topics. You've got Kafka Streams or ksqlDB that you can do all kinds of aggregations, branching, filtering, all this processing on their streams of data as it's coming through. So let's see how we can build this together into a more complex platform. So we start off with our application, right? Standard application. We've got our client. We've got a backend service. It's got its own database, and it's doing its thing, just happily chugging along. But the data that's going into that database is coming from events, right? Events are generated at the client, running through the service and landing in the database. And it's kind of like the database is where events go to die. They just sit there and they're not much more use anymore. You've lost the history as things change. You just have the latest information. So you decide you want to start capturing those events and opening up more opportunities for them. So you can bring in Kafka Connect. So every time something happens in the database, that's an event. Kafka Connect can capture that using a CDC or change data capture connector for whatever database you're using, and write that into Kafka. So now you have these events in Kafka topics. So you can start opening up other uses for those. So then you might add a streams application. So you write out a Kafka Streams application, reading from those topics. So as this is all happening while people are using the client there, it's writing to your service, it's going to the database, passing through Kafka Connect into the topics, being streamed into your Streams application. And there you can combine it with some other data, enrich it, filter it, do whatever you need to do there, and write that back to other topics. And then those topics, you can use Kafka Connect to send data from those new topics that were enhanced and enriched with your Streams application. You can send those right back into that same database. And so your your existing service might start taking use of some of those things, or taking advantage of some of the things that Kafka Streams can do for you, as far as manipulating and enhancing your data, and that can just grab that data from new tables in the same database if you want, or you could open up for other applications to use that. So you can add new applications now that can be working with that same data without affecting your initial application at all. You can create these new services that can use the data from those topics, or it might be sending new data to topics on its own. There's just all kinds of options that can do with that. Then you can even add KSQL DB. Say, for example, that new application you added, they weren't a Java team, they were a Golang team, but they still wanted to do some stream processing with that data as well. So they use KSQL DB, either read directly from topics again, or they can use the REST API and call KSQL DB to get that data into their application. So with all this data now flowing into Kafka and through Kafka, you might want to start doing other things with it, like perhaps adding some analytics. So you can, again, use Kafka Connect to stream that data out to Elasticsearch or some other analytics engine as you're going. Or other teams, might have downstream applications that could take advantage of this data, and you can use connectors to send the data out to other databases, and on and on. So there's just, this is a small snapshot of what you could do. There's so much more that can be done using Kafka in this way, and Kafka Connect really is a great enabler to allow you to use Kafka throughout your enterprise without breaking things. It's why I really love Kafka Connect. It's just a great tool for allowing us to capture the power of Kafka in an incremental fashion. So then in almost closing here, since I'm almost out of time, there's a blog post that shows how the New York Times stores all of their content in Kafka. And this is a snapshot of their high-level view of their architecture. But I would encourage you to read that blog post. It's just amazing. When I saw that, I was just blown away with how they're able to replay the entire history of all of their articles and picture, images, everything they've got, all their content. They can replay it and send it to the different sources or different consumers as needed. So if they ever went down, they could reproduce the entire thing from the Kafka topics. So they're storing a ton of data in Kafka, but it's there, it's accessible, and it's pretty fast. So I encourage you to check out that blog post. So like I said, Kafka is just a tool. It's one of many, and it's part of a broader thing. You can use lots of other databases, analytics engines, other data sources. They all work together. But this is, like I said, just a great tool for tying all those things together. So whether you're building something like the New York Times have done here with a full streaming application, or whether you're using it to decouple your feel free to throw questions in, because I know I almost use it all the time. Sorry, I thought this would go faster. What I've used Kafka for most of the times has been just to decouple microservices, get rid of all that HTTP chatter, and it's been great for that. It really cleans up a microservices architecture. Here's a slide I mentioned. It shows Apache Kafka from the Apache Kafka website. It shows 80% of all Fortune 100 companies are using Kafka to some degree or another, and their usage of it is growing. That's what will often happen. Once Kafka lands in an enterprise, it grows from there, because it's so useful. People start seeing it. Other teams start seeing the value of it, and it just grows. I've seen it happen at companies I've been at, where I was just at, and I've seen it now that I'm at Confluent. Speaking of that, I just joined Confluent this last month. I used to work for a healthcare company called Centene, which when I submitted this talk, that's where I was working. But I just was so impressed with the company Confluent and the way they supported the community. Like I said, software communities are important to me, and the Kafka community is just so vibrant. It's been such a joy to be a part of that community. And so the Confluent supports it so well. I've been really happy with that. So here's some resources that they provide that you can check out. I really would encourage you these books. They're all free, but they're very good books. They're not marketware, and they're just really good books. Also, the meetups. There's Kafka meetups are happening all the time. I really encourage you to join those. So the question here, someone asked about hosted Kafka services. The one I recommend the most would be Confluent Cloud. There's some others out there, MSK, and there's some others available too. The thing that I really like about Confluent Cloud is that because 80% of the committers on Kafka are working for Confluent, they basically get a head start on stuff. So it's the most up to date of all the hosted services. You'll be most likely to see the latest versions. when a new version of Kafka comes out, those features will be in Confluent Cloud long before they'll be in most of the other hosted services. They've got some pay as you go. They don't have a free tier, but they have a basic tier that's very inexpensive, and you can get coupons, which I don't have them with me, unfortunately. But you can find coupons all over the internet that'll give you so many dollars of free usage to kick the tires. But I would recommend Confluent Cloud. It's a great service, and it's just growing all the time. It's just amazing. The team that's working on it is really adding a lot of features quickly, and I'm just about out of time. So again, the meetups. There's one coming up next week on Kafka Streams. It's a tutorial workshop by Bill Bajek, who's the author of Kafka Streams in Action, and I really recommend that meetup. Kafka Streams. Kafka really helps with ETL workflows. Jason asked that question. I haven't used that much because I didn't come from a big data background, but I know folks who have. Robin Moffat, one of my coworkers, came from that background, and he's got a great talk on streaming ETL. If you can find him, you can just Google that, Robin Moffat, Moffatt, or just Google streaming ETL with Kafka, and you'll find his talks probably. And it's used to connect a lot of the other big data pieces that you're used to seeing, and using Kafka and Kafka Connect as the main pipe. So it's a great tool for that. Another thing I want to mention real quick is the community Slack. There's it's over 26,000 members in that Slack group right now, with over 50 channels of every different aspect of Kafka. It's hosted by Confluent, but it's an Apache Kafka Slack. It's really for even if you don't interact with Confluent in any way. If you use Kafka, you want to be on this Slack group. And it's very active, very helpful people. A lot of the Confluent engineers who do most of the work on Kafka, they are often in there answering questions, and they're very helpful. And then finally, you can reach me on Twitter or at my email. They're both on the slide there. I think I'm out of time. Is that right, Jay? But thank you for watching and listening. And again, if you have any questions down the road after this, feel free to reach out to me. DMs are open. Oh, I can still do some Q&A. Okay, great. So if there's any more questions, you can go ahead and post them there now. Or like I said, you can email me or reach me on Twitter later on. The Kafka community is pretty active on Twitter. There's I've got a Twitter list that you can find from my profile that's got a lot of the Kafka community members. There's just some really neat people. They're all over the world. And that's another thing I wanted to mention about the meetups. Because they're virtual now, obviously. I actually co-organized one in St. Louis. We had one event before the virus hit, and now they've all been virtual ever since then. But it's great. Now you can join them all over the place. I often will join the meetups in Europe or the UK around lunchtime. So, which is great timing for us in the US. But I've also been known to stay up in the middle of the night to catch those over in Australia. So it's a really great resource, a great community. I would encourage you to check out the meetups. And if you go to the Meetup Hub, you'll see all the ones that are coming up, as well as recordings from past meetups. That picture there is from a past meetup you can check out. So, any last questions there?
Okay.
All right. Well, thank you all.
Thanks, Dave. Thank you, everyone, for attending.